Good morning, everyone. My name is Ethan. Today, I'm excited to introduce you to the basic of computer system, the backbone of our digital world. We use this system every day, whether we are browsing the web, using apps, or working on documents. Let's break down their key components: the CPU, memory, data representation, and computer networks. Let's start with the computer's brain, the central processing unit. Executes all the instructions that make the computer work and consists of three main parts: the arithmetic logic unit, which perform mathematical operation like addition and multiplication, and logical comparison, such as checking if one number is larger than another; the control unit, which directs operation by following a cycle, fetching an instruction, decoding it, executing it, and storing the result. Register. These are ultra fast storage locations that hold data temporarily, such as a address of the next instruction, result from calculation, and data being transferred between the CPU and memory. Modern computers are based on the von Neumann architecture. This design includes five key hardware components: the arithmetic unit, control unit, memory, input devices, and output devices. In this model, all instruction and data are represented in binary 0 and 1, and programs are stored in memory so the computer can run them automatically. The CPU communicates with other devices like keyboards or printers through a bus, a shared communication pathway. Here how it works. Input devices send data to CPU, the CPU processes it, save results in memory, displays information on a screen or print it, and can even communicate with other computer via in a modem. Next, let's talk about memory, which store data and instruction in a hierarchy. As we move down the layers, memory becomes slower but larger and more affordable. At the top are register, fastest but smallest. Then comes cache memory, very fast storage for frequently used data, helping to bridge the speed gap between the CPU and main memory. Below cache is main memory, which include two types: RAM and ROM. RAM is random access memory, is volatile, means its contents are lost when the computer is turned off. Common type include DRAM or SD-RAM, which synchronizes with the system clock, and DDR SD-RAM. ROM, read-only memory, is non-volatile. Data remain even without power. It stored permanent instructions, such as those needed to start up the computer. At the bottom of the memory hierarchy is secondary memory used for long-term storage. Example included hard disk, which use magnetized platers; optical disc like CDs and DVD, read or written with laser; smart card, flash drive such as USB; online storage service like Dropbox. Third, how do the computer represent data? They use binary, only 0 and 1. A 0 typically represents no electrical current, while a 1 mean current is present to make long binary numbers easier to read. We often use hexadecimal, which use digit 0 to 9 and letter A to F. Data size is measured in bytes or beats. 1 beat equals to 8 bytes, with larger units like kilobytes or gigabytes and terabytes. Text characters are also encoded in binary. ASCII is a common encoding for English text, while Unicode support nearly all languages worldwide, essential for global communication. Data type include integer, floating point number, and Boolean true-false values. Logic gates are the fundamental building blocks of digital circuits. Basic gates perform simple operation, while combined gates carry out more complex tasks. They are essential to the operation of the CPU and memory, enabling all arithmetic and logic function. We also use encryption and compression to handle data securely and efficiently. Encryption convert readable data into unreadable form to protect provides with two main types: symmetric private key and asymmetric public key. Compression reduce file size. Lossless compression like zip or pinch preserve all original data, while lossy compression like JPEG or MP3 achieve small size by removing less important information, ideal for image and audio. Image and sound are also digitalized. Image are made of tiny dots called pixel around in a grid with color often represent use the RGB red, green, blue model. Sound is captured by sampling and converting each sample into a number. Both are stored as binary data along with metadata such as image dimensions or auto quality. Finally, computer network connect device to share resources and communicate. They allowed us to share printers or files, communicate via chat or email, backup data securely, and access remote database. Network are categorized by size: WAN, MAM, and LAN. They require hardware, connectivity method, and software to function. The World Wide Web uses HTML to create web page. A website is a collection of web pages under a single domain name, hosted on a web server and accessed through browser like Chrome or Firefox. How do the internet work? There are two common models: are client or server and peer-to-peer. Network can also be organized in different top um, topologies such as bus, ring, and star. In summary, computer systems are complex yet fascinating. Understanding these fundamentals help us better comprehend and utilize the digital tools we rely on every day. Thank you for your attention. Thank you.